when we need to integrate Salesforce with other system, or we just would like to notify another system that something happens in Salesforce, we could use event-driven architecture. So when we're working with event-driven architecture, we don't need to use a pooling. We could use just events in order to be able to notify another system that something happens. So for example, we could use platform events. So it's actually, they are allowing us to create a custom message, and somebody could actually subscribe to that message after we will publish it. So it's actually need for us to notify the system about some specific events which happens in the system, like for example, order created, case escalated, opportunity created, whatever, right? What is our use case? And it's actually allowing us to, let's say, make an asynchronous work, because publishing an event generally runs outside of the current transaction, right? So it's actually help us to avoid lock row and limits related to the transaction flow. So also it allows us to scale our system, like for example, events resides on the event bus, which is designed to handle massive traffic volume. So that means that, we should not reach the limits, plus it gives us a separate transaction, right? And it's also loose coupling decoupling. So the event publisher, for example, Apex Trigger, does not know or should not take care about what is actually happens with this platform event, who receive it, who is actually subscribed, and so on and so forth. It might be some external system, another internal Apex class, or it might be Flow, or wherever is our architecture. So another way for us to actually work with events is to use change data capture. So it's about real-time data replication. So it's actually a specific time of platform event, right? So for you to understand, it's also platform event, but it's a specific one, right? Standard one available out of the box. And Salesforce publish automatically it when some record is actually changed or if some specific update happens. So it's used for real-time data replication to external data warehouses or other systems that need to maintain a near instant copy of Salesforce data. So if we will compare or change data capture with triggers, we will find out that Apex triggers fires inside the transaction, which is affect the CPU and SQL limits. Change data capture is actually published after the transaction is committed, so it actually consumes no transaction limits and guaranteed data is reliably saved. So then architectural rule when delivery data changed to external system delivered, then we need to prefer to use change data capture over traditional Apex callouts. All right, what is key architectural patterns? Let us read through it. So if we're using event-driven microservices, it's for internal or external microservices reacts to event published by Salesforce using them as triggers for their specific business logic. So what it means? It actually means that if we publish some event on the Salesforce platform, some subscriber will only react to our event only when it's actually published. And tools for that we will use it might be platform events or change data capture or external ESB or middleware. So event bus as a mediator. Salesforce publishes an event to high volume bus, like for example Kafka, which then mediates and distributes it to multiple varied customers. So we could use external middleware, change data capture, or platform events. So then we have a platform event chain. One event launches a synchronous Apex logic, which upon completion publish a new event to trigger the next stage of the complex project process. So sometimes it's required for us to do so when we would like to notify systems that, for example, our event is just finished. We could, start, for example, to do a recalculation or some updates. So for this, definitely it's good to use platform event change. So just a quick overview as a topic of the day related to our event-driven architecture.